Okay, so we're back for part 2 of this circuit. Ohm's law, remember this guy? E-I-R before, but now it's E-I-Z. Z is for impedance. You do the same things. So in a series circuit, what's constant? It is your current. Same thing for AC. So now we have to find I total. So E divided by Z gives us I. So we take 15 at an angle of 10, which is our E total in VRMS, phasor voltage, divided by Z total, which is 2.508 K ohms, at an angle of 37.12. This is going to give us our I total. Okay, so we have 15 at an angle of 10, which is our E total, divided by Z total, and I can, since it was the last thing, I can just do shift answer. It pulls the last answer, and this is my current, 5.98. If it gives you this, it's already put into milliamps at an angle of negative 27.12, because you want to round this number up. So our I total is 5.98 milliamps at an angle of negative 27.12 degrees. What's constant, I said again, is this current. So this is the current running through this circuit. They all have the same current. So how do we get the voltage drops? By simply adding I times R1, I times L1, which is the reactance, I times C1, the capacitive reactance. Those three voltages must add up to the total applied voltage of 15 at 0. I like to store my entire current in there, plus it makes it a little bit easier. So this button here says, yo, store that number, and I like to use alpha Z because it's the bottom last, and then you can press execute. So now you know that that current is stored in your calculator. So it's very easy to get the three voltages. It's just alpha Z times the first one, which is 2K at an angle of 0 equals. So V R1 is going to be 11.96 volts at an angle of negative 27.12 degrees. The next one we're going to do is VL1. So we're going to do alpha Z times the inductive reactance, which is 2.011 K at an angle of 90 equals. So now for VL1, we have 12.03 volts at an angle of 62.88 degrees. Last one is VC1, which is the voltage across the capacitor, alpha Z times 497.36 ohms at an angle of negative 90 equals. So we should have 2.97 volts at an angle of negative 117.12 degrees. The last thing you need to do is add all three of these up and make sure that it adds up to the applied voltage, which is 15 at 0. So I'm going to do that. So this, I'm just going to add plus, and it'll put that last answer. I'll put the next one, 12.03 at an angle of 62.88, plus this voltage, 11.96 at an angle of negative 27.12. It should all add up to 15 at an angle of 10, if we did it right, which I'm sure we did. So here it is. So to prove it, it's 15 at an angle of 10.011. Close enough for government work. Look at that. Tell me how much fun that was. See you on the next video.